Hi. I'm sure we all saw this spectacular landing of the Perseverance rover on the Martian surface as part of the NASA's Mars 2020 mission. Now, as we admire and scroll past these images that the rover sends us as it's walking and parking on this foreign land, what we might not stop to think about is its ability and its kind of desperate need and search for life and clean water to save our own planet. As clean water is quickly becoming a precious resource for the 21st century, the socio-economic and the technological challenges associated with water production, um, availability, and recycling need a new solution. Now, the recent report from the Desalination Association says that about one 1% of today's population is dependent on desalinated water, and that about 14% of the world's population in about 2020 is expected to be in water scarcity. um, these are shocking numbers and figures, but to our rescue, about 10 years ago, a new material was founded. A single sheet of carbon that was isolated, this material called graphene, and this won the Nobel Prize in Physics in the year 2010. And this material led to a discovery of plethora of other two-dimensional materials, or so-called 2D materials, which are essentially just a sheet of paper but at nanoscale, where the height dimension of these materials are negligible, or say it's one atom thick. Now, this is what I've shown in the slide, the image on the right, in a black and white image, where the bright spots are single atoms and the dark spots are atoms that have successfully kicked out using my fancy lab tools like the ion and the electron beam. Now, to create these next generation solutions, we need to understand the fundamental ionic transport and like water molecular transport at an atomic scale. Now, this is what my research at Penn is focused on. Where we create these I grow these ultra thin films in really hot ovens that are about 100,000 degrees Celsius. It's like baking, but very hot. And I use techniques from the field of nanotechnology to develop these nanopores and nanoporous materials. And I study the ionic translocation across these membranes using state of art electronics. And I study these small nano level currents. And this tells me a lot about how the molecules transport. This is very interesting and important because 2D materials are the thinnest material possible, and they will therefore allow for maximum flux to go through. It's like designing a toll gate where we're trying to only pass the small cars and block the big vehicles, like the big salt ions I show in the left image. And it's like also making these small ions pass through, like as though they all carry an easy pass and they go really swift. And so, in next time you're passing a toll gate, remember that in my nano world, this toll gate is just a missing atom. Thank you.